So what we have here is a heavy equipment transport, a HET, and it used to be manned, but then we added some sensors, some actuators, and then some computers and software, and now it drives itself.
Autonomous vehicles often have lots of different, what we call attack vectors, open surfaces in which you can remotely get into a vehicle, like through a radio or a USB stick that you can program so that it can call out over those radios.
It takes a lot of computer code to have a truck like this start, steer, shift gears, and stop by itself. And the more lines of code, the greater the risk of vulnerabilities for cyber attackers to exploit.
You can actually send commands. In this particular case, I'm just telling the horn to come on. I can turn that off. So that's how easy it is.
We're showing that conventional software and that particular software is vulnerable to attacks because it's written by humans. Humans make mistakes, and mistakes can be exploited by the bad guys. They can steal the truck, turn it into a weapon. They can do anything they want to with the vehicle. And the objective is to obviously prevent them from doing that.
Can Hacms help protect equipment like this from cyber attacks? Using the Hacms tools, the HRL team rewrites the critical program lines of the HET computer code.
We're doing proofs of facts about some of the software that we're using on the truck.
So this box is the same kind of computer that we have on the truck. This is actually the Hacms software. This little thing is what drives this huge truck. What we did is replace some portions of that software that takes the sensor inputs and decides how to steer, how to speed up, how to slow down, and implemented them using Hacms tools to make them both resilient and secure.
Would the Hacms version of the code work? Would the HET be able to drive itself? And would the new code be secure? The truck was delivered to Assured Information Security in Rome, New York, into the arms of the Red Team hackers to find out.
My name is Eric Thayer. I am the Red Team lead for the DARPA Hacms program, and we serve as the voice of the offense. We try to make the system fail. We try to make the system do something it's not supposed to do.
The Red Team is analyzing the system program, looking for ways to beat Hacms, and looking for holes in the programming architecture that would allow them to work around the secured software. Before Hacms, the truck wasn't much of a challenge.
It was pretty easy. We could walk up, we could say, hey, look, this system does this. I can make it not do that.
The truck will drive a path, approach an obstacle, and stop.
Ready to go?
We launch from one end of the test facility down there.
We're letting it navigate on its own.
We drive a zigzag pattern, very similar to the pattern that the HRL guys set up when they were here.
And that is testing its security functionality to make sure there's no collisions with either pedestrians, objects, or buildings.
As the truck creeps up to the target, it will apply the brakes gently to determine if the surface is slippery or not, and then it'll hit the brakes and stop the vehicle.
The truck drove like it was supposed to. The Hacms code did not affect the autonomous program. Now, is the new code secure?
After we demonstrated that that process worked like it was supposed to, we then added the attacker into the mix.
It's not going to be smooth, it's not going to be pretty.
The Hacms tools, the tool chain, the pieces that have been developed can be applied to any target system. The biggest thing is figuring out which components, which pieces of that target system need to have that application.
It's trying to tell it to the engine to stay idle, and I'm trying to tell it to go 100% throttle, wide open.
What is it that may be secure? What is it that may need to be secure? And what is it that doesn't truly matter or can be left over here in an insecure mode?
The 20-ton truck sensed the obstacle and stopped. The hackers could not get into the secure Hacms partition.
By taking the Hacms solution, you can then apply a level of security to those platforms that wasn't originally designed, wasn't originally built into it, that sets the bar much higher and makes it much more difficult for an adversary to be able to gain access or influence the operation of that system.